Okay, so today we're gonna start with we're gonna prepare for percent and proportion. Okay, so first, what is fraction, what is ratio? So it's a part of a whole. So if you have a pizza or a pie and you eat one piece of it, getting the ratio, the proportion or fraction is, you need to count how many pieces. So the first example here you have this little circle divided by 8. So it's like a pizza divided by 8 pieces, and you have 1 out of 8. Okay, so that's the fraction, or that's the ratio of the segments which is shaded. And that's all what you need to do. You have to see how many pieces are shaded over the total number. Okay? So the same way, number 2, if you look at the second circle, you have 3 pieces out of 8. So that's it. The next one, can you tell me number 3, how many pieces we have? How many are shaded in number 3?
6 out of 8, which can be simplified, right?
6 out of 8, good job. And you can simplify this. How you simplify, reduce the fraction, divide by the same number up and down. So I'm going to divide by, you can divide by 2, so that gives me 3 over 4. So that's the fraction. Okay? So that's how you get the fraction, the ratio. Now, the next examples we have, they are not circle, it's a little squares or rectangulars, doesn't matter, they're the same size, and you're doing the same way. So you're gonna have how many shaded blue here? Now for number 4, there are 2 shaded out of, how many is the total? Out of 6, right? And 2 over 6, you can reduce that, is gonna be 1 out of 3, 1/3. And I'm gonna box the answer, so that way when you look at the notes, when you look at the examples, you know which one is your answer. Okay, I'm gonna box the answers all the time. Okay, the next one we have number 5. For number 5, how many are shaded? There are 2 out of 3. Okay, because there are only 3 boxes here, 3 squares. Okay, and then number 6 is the same way. We have 3 shaded over the total of 4. So that's the answer for number 6. Okay, so that was the question here they're asking. Now they want us to get the shaded fractions, and also they have question, determine which ratio equivalent. So which ratio equivalent? Do we have equivalent ratios? Okay, the answers we have, they're all different, but what they mean, which ratio are equivalent? Equivalent ratios are when they represent the same amount. So like 6 over 8 is the same like 3 over 4. Make sense? Also, 2 over 6 is the same like 1 over 3. That's what equivalent ratio means. And number 3 and number 6 are the same. That's right. That's right. Good observation. So I have number 3 and number 6 are equivalent. So technically it doesn't matter if you have circle or you have rectangulars, the proportion, the part out of the whole is the same fraction. Make sense? Any questions so far? Okay, so we're going to the
Any-
next one. Yes, questions?
Aren't there any on the bottom, like for number 7?
Oh, there's one more in the bottom. Okay, yes, let's go. Oh, yes, thank you. There's one more in the bottom. Thank you. Okay, so for this one, how many? So here, what you're going to, okay, let's see. This is a little different and tricky. So what you have here, you have one piece and more. So this is one shaded plus how many shaded? 2 out of 3, right? So 1 and 2 over 3 is actually
1 and 2.
1 and 2/3. So this is called mixed number. 1 and 2/3 is the mixed number. And do you guys remember, or do you know how to change mixed number to improper fraction?
Yeah, you multiply the whole
Multiply, multiply those two. So you're gonna multiply, and you're gonna add this number, add 2.
Yeah.
So it's gonna be what? 3 plus 2, 5 over 3. Okay? So that's the improper fraction. Improper fraction is 5 over 3, and the mixed number is 1 and 2/3. So in this case, doesn't matter which one you're going to use, because both of those form of the proportion of the fraction means the same. Okay, so that was writing the proportion, writing the fractions using the graphs you have. Okay, so now here we have to do it backwards. They're going to give me a picture. They're going to give me a fraction, and we want to draw a picture which represents. Okay, we need to draw 1 over 4 and also 4 over 1, and you have to discuss, are they equivalent? Obviously they're not equivalent, but let's see how they look like. Okay, so I'm going to do this one here, and we're going to do with another color this one. So can you tell me how to do the first one? How to do the right one? 1 over 4. You want to draw a circle, or you want to draw a rectangle, or what you want to draw?
Do the rectangle.
Okay, so I'm going to have, it's something like, it could be like a square, doesn't matter. And I'm going to divide it by 4, right? Now, it doesn't matter how you divide it by 4. It could be diagonals, it could be like this, doesn't matter. There are different ways to divide it by 4, right? So you can do the same rectangular. I can divide it by 4 like this, right? It doesn't matter. You still have 4 different pieces. You can divide it by 4 vertically, or you can divide by 4 horizontally. Doesn't matter. So these are different ways of dividing one piece by 4, right? So we divide it by 4, and we have to shade how many? 1/4 is one of those. That's right. So I'm going to shade only one of those pieces. You can shade it if it's this one, or it could be like this, doesn't matter. Both of those represent the same fraction, right? 1/4. I'm going to make it a little messier. Okay, so this is the graph of 1/4. Now let's do the 4 over 1. What is 4 over 1? You're going to divide it by 1, which means you're going to have a whole piece. It can be a rectangular also, doesn't matter. Or you know what, let's make it better. So I'm going to take the same. You're going to divide it by 1 means I'm going to keep it a whole, and I'm going to get 4 of those. I'm going to shade 4 of those, right? I'm using rectangular because that's how we start, so it kind of be consistent. So here we're shading this. Oops. We're shading these 4 whole pieces. 4 over 1 is technically 4 whole pieces, right? So now, are they equivalent? Are they the same?
No.
No. That's right. It's not, they're not the same. Okay? Any questions on this? Okay. The next example we have is number 9, when it is necessary to write 1 in a ratio. Like if you have 4/1 or 1/4, which way you have to put the 1? Is it necessary to put 1?
Like when there's only one piece shaded?
Okay, so if it's only one piece shaded, you put 1 over, right? So if you look at the fraction, the example we just did, we have 1 here in the top and you have 1 in the bottom, right? So where you have to put 1, in the top or in the bottom, it's important to put that 1. What do you think?
Did you put at the top?
You have to have the top, that's right.
Mm-hmm.
So what that means is, let me see if somebody else say something. Top. Okay, so you have to be in the top, right? Okay, so you have to put 1 in the top, but putting 1 in the bottom, it's optional, right? So this is what you have to know and what you have to remember about fractions. So when you have fractions, fraction is you have numerator over denominator. So you have something in the top, something in the bottom, right? You have a number in the top, number in the bottom. So when you have fraction, the denominator, if the denominator is 1, you don't have to put it. But if the numerator is 1, you have to put it, okay? Give example, demonstrate when it is not necessary to write. Okay, so I'm gonna give example. So if I have 1/5, this one have to be there, okay? But if you have 7/1, this one in the denominator is the same like 7. You don't have to put it. Make sense? So 1/5, if I have 1/5, it have to be 1/5. You have to keep the 1, okay? But if it's 7/1, you can just forget about the 1 in the bottom. Make sense? So when the denominator is 1, it's a whole number. You got it? Everybody understand the concept? Any questions? Do you guys want to give me another example? Give me an example where I have to keep the 1. So give me another example.
6/1.
6/1, do I need to keep the 1?
No.
Okay, 6/1 is actually just 6, right? That's right, good job. Okay, what else? I have another one in the chat. Okay, you say no, you don't have to keep, yes, that's right. So everybody understand this, right? So if you have 1 in the bottom, you can forget about it, okay? Okay, so that's what we have here so far. Any questions about fractions? Everybody good? Okay, so here we have another concept. We have to identify the part from the whole, then form the associated fraction. So here we have number 10. It says Tony tipped $8 on a 22.58 ticket. So what that means?
Does it mean that $8 is the part and the whole Number is 22.58, so you would do 8 over $22.58.
Good job. Good job. That was Alexandria, right?
Mhm.
Good job. Yes, absolutely right. Yes. So $8 is the one, the part of 22.58. Okay, so this is the fraction. Okay, now let's look at the, I mean, you can reduce this if you want, but we're gonna just leave it. That's what they asked, just to form the fraction. So here we have, the next one is in an 82 game regular season, the Spurs won 58 games. So how many games they won? So which one is the whole and which one is the part of it?
Would the 82 games be the whole and then the 58 be the part?
Yes, yes. So part of the games they win, Spurs win. So part of the games they lost, right? So you're gonna have the part is gonna be 58 out of 82 games. And that's the fraction. Good job. What is the next one? Let's see the next one. Northwest Vista College has 15,435 students. 4,630 of them all transferred to UTSA. So which one is the part, which one is the whole? Okay, that's right. Mallory has the answer in the chat. It's 4,000, the student who transferred to the UTSA, 4,630 out of the whole student population at Northwest Vista, which is 15,435. That's right. Good job. Now, good job. Everybody understand that? So going to the next one, we have number 13. Sam has caught 212 out of 802 Pokemons. So what is the whole, what is the part?
Miss, can you zoom in some? Because it's really hard to see.
This one has what?
Can you zoom in a little bit?
Oh, zoom in. Like, okay, sorry. Yes, I can do that. Absolutely. Okay. So 12 out of 802 Pokemon. How many? What is the whole? What is the part? Yes, that's correct. Good job, Crystal. It's 212 out of 802 Pokemons. Okay. The next one is my paycheck will have been 950, but 170 was taken out for income tax. So what was taken out? What was the part? Okay, so this is a little tricky. Let's think about it. So 170 is the part, okay? It's taken out of 950. That's correct. Good job. Haiti is on 5 3/4 hour car trip. She has driven 2.5 hours so far. So what is the total? What is the part of it?
The total is 5 3/4, and then the half is 2 and
So
1.
that's the whole part. That's right. So that's going to be in the denominator, 5 3/4 and 3/4. And in the top is going to be 2.5. Okay. Any questions here? Do you guys know how to simplify this fraction? You have mixed number over mixed number. Let's just go over kind of review how to simplify fraction like this. So how you simplify fraction like this? I'm gonna make the mixed number to improper fraction. So I'm multiplying 2 times 2 plus 1 is 5 over 2 in the top. And then the bottom fraction become 5 times 4 is 20 plus 3 is 23 over 4, right? So here we have fraction over fraction. You reduce this when you divide the top by the bottom. And I'm going to write it step by step. So it's going to be 5 over 2. Oops. 5 over 2, I'm going to divide by 23 over 4. And when you divide fraction, you technically multiply by reciprocal. So you're going to flip the second fraction over. And this division become multiplication. So that's how you do the operations here. That's how you simplify. So we're going to have 5 over 2. We're going to have 5 over 2. And you're going to multiply it by reciprocal, which is 4 over 23. Everybody understand that? And here we're going to reduce. So we're going to simplify. Before I multiply straight across, I'm going to reduce 4 and 2. I'm going to divide by 2 up and down. So it's going to be 1 and this will become 2. And then after that, I'm going to multiply. 5 times 2 is going to be 10. And 1 times 23 is 23. So my reduced fraction, simplified fraction is going to be 10 over 23. Any questions here? Yes, go ahead.
No, I was just saying you were muted.
Oh, I'm sorry. Okay. Okay, so everybody understand that one? Okay, let's go ahead and go to the next one. So the next one is going to be solve for the variable. So here we're going to solve equal. Okay, so the next one we're going to go is we have to identify how the following numbers and variables are held together by addition, by subtraction, multiplication, or division. So you have to identify what is the operation between them. Okay, so for example, in the expression x plus 5, the variable and the number are held by addition. So we're going to go through this and you're going to say what is the operation between the number and the variable. So that's what you need to look. What is the number and what is the variable? Okay, the variable is usually the letter X, Y, whatever is the letter, right? P. So now, number 16A. So what we have between X and the 5?
Subtraction.
Subtraction, that's right. So operation is subtraction. So that's what you're going to get there. Now for B, what is the operation between 5 and X? What is this operation?
Multiplication.
Multiplication. Now the next one is X divided by 5. The operation is division, right? That's the symbol for dividing. Okay, between 7 and plus X is addition, right? Now between 7 and X in E, what is the little dot there represent?
Multiplication.
Multiplication, that's right. Multiply. Okay, next one is negative 7 plus X. What is the operation between those? It's addition, right? Now, G, we have X over 7. What is the operation?
Division.
Division. Between 7 and X, there is nothing there. What is the operation?
Multiplication.
Good job. We're going to multiply. Now, next one is a little tricky. 2 over 5x, what that means? So now here, 2 over 5 is the number, right? So keep in mind, it's not division. It's 2 over 5, it's in front. And x is in the end, right? So x is here. So the operation between those two is multiplication.
Multiplication.
Good job, Morgan. Yes, multiplication. Oops, sorry, I put this. Multiplication. Okay? So here it's multiply. Okay, next one. P times 250, obviously it's multiplication. The next one is also multiplication. And the next one, now what is the next one? X over 1000 times 54. What is the operation here?
Division.
Division. That's right, because X is in the top and the number is in the bottom, right? But this multiplication is technically like this. What is it then? Because you have divided and then multiplying. So between X, so it's not exactly like this. It's X divided by, I'm gonna rewrite this so you can see what that means. Now, when you have multiplication and division in one problem like this, you have to go left to right. So you're gonna do X divided by 100 and then times 54. So between X and 100 is division. Okay, everybody get that? Okay, that was kind of easy, right? Okay, number 17. What operation do you use to undo addition? Opposite is what?
Subtraction.
Subtraction. So remember the inverse operations where you undo something, they're like multiplication and division, they're inverse to each other, they cancel each other, undo each other. The same way addition and subtraction, okay? So plus and minus cancel each other, multiply and divide, they cancel each other, okay? So here we have, I'm gonna do the addition needs subtraction minus. How you solve this problem? X plus 5 equals 19. We're gonna subtract 5 in both sides, right? That's how you're gonna solve it. Okay, and the next one the same way. You have X plus 20 equals 75. You're gonna subtract 20 in both sides. That's how you solve these equations. When you have X plus number, you subtract it. And it's gonna give me X equals 75 minus 20 is 55. So that's how you solve it all the way to the end. You solve it. The same way this one, you cancel positive 5 and negative 5, they cancel. So you get X equals 19 minus 5 is 14. I'm just gonna solve it to the end, okay? Because that's what you're gonna try to do here. We're trying to solve the equation, okay? The next example we have is undo the subtraction. Undoing subtraction, its opposite is addition, right? So we're gonna add. So the equation we have, how to solve X minus 5 equals 2. You're gonna add 5 in both sides. And why are you adding in both sides? Do you know? Because it's an equal sign in the middle, it's balance. Whatever you do in the left, you have to do the same in the right side. So if I add 5 in the left side, I have to add 5 into the right side of the equation. And these are the two sides of the equation. C equal is here, so these are the two sides. So we're adding 5 in the left side, we're adding 5 into the right side of the equation, okay? So always keep that in mind. And then what is left? We have left with X equals 5 plus 2 is 7. Okay, so that's how you solve it. The same way you're solving X minus 12 equals 30. You're gonna add 12 in both sides. And that will give me X equals 42. Everybody understanding this? Any questions? Okay, so the next one, we're gonna do the opposite of multiplication is division. So I'm gonna divide. Okay, now division can be with the sign divided. You can also use the fraction divided by, right? So how you solve 3x equals 63? Between 3 and x is multiplication, so you're gonna divide by 3, both sides. Now 3 divided by 3 is going to be 1x equals 21. Because 63 divided by 3 is 21. And the same way you solve in 4x equals 88. How you solve 4x equals 88?
You divide 4 on both sides to get x.
That's right, you divide by 4. And why you divide by the same? Because 4 divided by 4 is what? 1x.
Cancels out. Mhm.
Yes, 1x equals 22. Okay? Now, number 20. You guys tell me this. X minus 3 and negative 3x, are they the same? Are they the same or not? Oops, what's happened? Okay, there you go. So I
No,
have,
they're different.
they're different?
Mhm.
Why they're different? What is the operation in X?
Because one of them you're subtracting 3 from x, and then the other one you're multiplying -3 to x.
Yeah,
Yes,
different
you're
values.
multiplying, that's right. Yes, good
Yeah.
job. So the operations are different. Now, how you solve x minus 3 equals 12?
Add 3 to both sides.
You're gonna add 3, that's right. You're gonna add 3 in both sides. And I'm gonna write it here. So you have x minus 3 equals 12. You're gonna add 3. And you're gonna get x equals what?
15.
15, that's right. And if I solve the other one, I have negative 3x equals 12. What operation I have to do here?
Division.
Divide. Here I'm gonna divide by, what you're dividing by?
-3.
Divide by -3, that's right. Because -3 is the number in front of x. So you're gonna divide by -3 both sides.
Mhm.
And then you're gonna get x equals,
-4, because every time
Oh.
you divide is a negative.
yes, good job. When you divide positive and negative, is gonna be a -4. That's right. So you see, you get totally different numbers there. Okay? Everybody understand that? Any questions? Okie dokie. Going to number 21. 21, we have, what operation does a fraction bar stand for? What is the operation? Like if you have 1 divided by, oh, sorry, 1/2. The bar, so this line here, what is the operation?
Division?
Yes, absolutely, yes, it's right. So the bar means division. Okay? What operation do you use to undo this operation? What is the opposite of division?
Multiplication.
Multiplication. Okay? And so then how you solve x over 4 equals 15? What you have to do? What you have to do? What you have here? You have x divided by 4, right? So when you have x
Multiply
divided
4 by each side.
That's right, you're gonna multiply by 4 both sides times 4, okay? So this is what happened. You have x over 4 equals 15. So I'm gonna multiply by 4 in this side, and I'm gonna multiply by 4. I'm using dot for multiplication. Now this is 4, is technically 4 over 1. So 4 up and 4 down cancel, and you have only left with x. And then you multiply 15 times 4 is 60. So when you have division, you multiply by the denominator, okay? Let's try the other one. So here you have x over 5 equals 20. So what you're gonna multiply by? If you have x over 5, x over 5, you multiply by 5. And 5 up and 5 down cancel, so you get x equals 100. Okay? Everybody good so far? Questions? So that's how you solve simple equations. Okay? The next one is number 22. What if there are numbers attached to the variable by both multiplication and division? So you have multiplication and division. What you're going to do? So you're going to undo, you're going to get x by itself when you do it step by step, right? But you can do it together. So this is what you're doing. The 2 is attached. What is the 2 attached to the x? Is it by multiplication or addition? Or subtraction, or what is the operation between 2 and x? So 2 and x, how they attach? I'm sorry?
They're being multiplied.
That's right, multiply. So how to undo 2? What you need to do? What is the operation you're going to do? The opposite of multiplication is division, right? You're going to divide. Okay? So because between 2 and x, we have multiplication. So if you want to cancel the 2, undo 2 means cancel it out. You're going to do opposite of multiplication, which is division. You're going to divide both sides by 2. Okay? Now, looking at 5 is attached to x by what? By division, right? Because it's x over 5. And how you're going to undo, how you're going to cancel the 5? You're going to do opposite of it. You're going to multiply. That's right. Everybody understand that? So now, how you going to solve it? So this equation we have here, 2 over 5x equals 10. I'm going to write it so I can have room. 2 over 5x equals 10. So what I'm doing, I'm gonna divide by 2. So I'm gonna do it like this. Divide by 2. Divide by 2. So technically, you're gonna multiply by fraction. Divide by 2, right? And I'm gonna dividing by 2 and multiply by 5. So multiply by 5 means up 5 and down 2. So technically what you're doing, you're multiplying by reciprocal of the fraction next to x. You're dividing by 2 and you're multiplying by 5. So these 2 cancel out. Everybody see that? So 2 and 2 up, 5 and 5 up and down, cancel out. And what is left? We have x equals. Now how are you going to simplify this? See, 10 is over 1. And you can multiply straight across if you want, or you can reduce first and then multiply, doesn't matter. So it can be 50 over 2, which is 25. Okay, everybody good? Any questions? So when you have, remember, when you have fraction next to x, see this is a fraction in front of x. If you want to get x by itself, this x by itself, you're going to multiply left and right side, both sides, by reciprocal. Reciprocal means the fraction upside down, flip it over, okay? Any questions? Okay, let's do 23 and 24, the same way. So 23, if you have x in the denominator, what is the operation we're going to do? So here we're going to do, we can do cross multiplication. So I'll show you what is multiply. That's right. You're going to cross multiply. So this is how you cross multiply. Now 45 is over 1, right? So when you have fraction equals fractions, then you're gonna cross multiply. You're gonna multiply, so you're gonna multiply this times this equals this times this. This is the cross multiplication method. Okay, and this is very fast method to solve when you have fraction equals fraction. So what you, or just fraction equals number. So what you're gonna get, x times 45 is 45x equals 9 times 1 is 9. And then what you're doing from here, in order to get x by itself, we have to divide by what you're dividing by. What is the number you're going to divide by to get x by itself? 45, that's right. You're going to divide by 45 and you're going to get x equals. Now here you can divide by 9 up and down. You can reduce this. So it's going to be 9 divided by 9 is 1. 45 divided by 9 is 5, right? So it's going to be 1 over 5. That's how you reduce it. You can divide by the same number up and down. But the answer is 1/5. Okay, let's do the next one the same way. So here we have, so how you gonna do it? You're gonna cross multiply, right? That's the fastest way to do it. So multiply those two and those two. Doesn't matter which one you're gonna put first. Doesn't matter. If you want, you can do 9 times 100 is 900, right? Equals 45x. And then what you're doing to get x by itself? Between 45 and x, we have multiplication. So we're gonna divide by 45, right? And these two cancel out, right? Everybody see that? And then you're gonna divide 900. When you divide it by 45, what is that? It's 20. Okay? Any questions? And then you have more equations here to solve. Okay, so this is the last page. I'm gonna stop here. So what you have here, you know what, let's do this. You guys wanna do this for homework? Yeah, let's do this for homework, just to solve those 10 equations. Okay, so we're gonna leave this for homework, just to practice. And this is what we're gonna do. We're gonna leave this. Are you guys okay to practice this? Do it by yourself, solving this equation and get x or p by yourself, by itself. Can you do that?
Yes.
Yes? Okay, good. So so finish this. You can write it in paper. Solve it on paper if you want to print it out, or just solve it in your packet. So this is going to be for homework. Everybody have access to this, right? Now finish it, and next time I'm going to show you how to attach your homework. Okay? Now let me ask you, do you guys know how to scan paper with your cell phone? Yes or no?
Yes.
Yes.
Yes? Okay. Yes. So this is what I want you to do. So for next time, if you have the packet, just solve these 10 questions. That's the homework for today. And I'm going to include it in the, when I attach next, for next time, you're going to have everything on your, everything is going to be on Canvas. So when you go to Canvas, in files, I'm going to fix this. I don't know how to, I'll try to delete all this stuff, but you're going to have like calendar, something like this, where you're going to have homework, and this is what you're going to go in class. Okay, and here in the homework you're going to have, so the full homework, so this is not, this is from my last year class. I was teaching 13-14. So for this one, can you put your email? Yes, absolutely. Thank you for that. Yes, I'm sorry, let me get there. I'm going to stop sharing. Thank you for asking that. Yes. I'm going to put it to everybody. So this is my email. It's riyyinbor@alamo.edu. So this is my email. You guys get my email? Okay. So today, after we finish the class, we have 10 minutes. I just wanted to make sure everybody clear everything. So my email is riyyinbor. And